Hey guys, welcome to section 6.4. Today we are going to be comparing different sinusoidal functions. So we're still looking at the sine functions. It's just a matter of how they've been stretched, compressed, elevated. So we're just going to change different parts of them. I'm only going to look at one example today. Essentially all we're doing is looking at a Ferris wheel that is rotating around, and we're going to look at how long it takes for the Ferris wheel to complete a full cycle and things like that. So I've got 3 different graphs on my next slide, each one describing a different Ferris wheel. We need to figure out how long it's going to take for the Ferris wheel to go around once. We want to know how high above the ground the axis is. This would be your equation of the axis. The radius of the Ferris wheel, so from the center to the outside, which we talked a little bit about yesterday. The circumference of the Ferris wheel, how large it is going around, and then how quickly it is traveling if you were a rider on the Ferris wheel. So each one of those little parts describes a specific part of your graph. So, and really all you're doing today is you're just going to be comparing different types of sine functions or sine graphs. So let's look at each one of these. So when we're having a sinusoidal function and you're imagining a person on a Ferris wheel going round and round, the revolution time is how long it takes for the person to go around the Ferris wheel one full time. So really what they're asking for is the period of the function. So again, if we have our circular Ferris wheel, if I get on the Ferris wheel at the bottom, the revolution time is how long it takes to go all the way around. So if you imagine starting at one point, going around and ending at the same point, what they're really asking for is the period. So we're starting here. I mean, in this example where I've looked at it, we go all the way around and then we start maybe here. Sorry, stop here. So this would be the cycle. The distance from here to here would be your revolution time. So it ends at 40 and begins at 0. So the revolution time is 40 seconds. Maybe, I'm not sure if maybe we should do the revolution time for all of them. We'll compare at the end. Okay. The height of the axle, so that would be the center point of your Ferris wheel. So the axle would be right in the middle. If the Ferris wheel is right there, I mean, there could be something built up for you to get on it, which is why we're starting here. But really what they're looking for is the center. That would be your equation of the axis. So we're looking for this line right in the middle. Okay, I didn't quite draw it in the right spot, but you get the idea of what's happening. Oops. Uh-oh, what happened? We're just gonna put that back. Okay, so the height of the axle would be this line. So remember, you can take your maximum and subtract your minimum. My lowest point looks like it's 1 and my highest is 13. So I can take 13, add it to 1 and divide by 2. I'm taking the average between 13 and 1. That should give me 7. And if you look at my line, I mean, I didn't draw it in the right spot, but yeah, it hits at 7. So this is 7 meters. Okay, so the axle is 7 meters above the ground. The radius of the wheel would be the distance from here right to the edge. In other words, you're looking at the height from here up to the top, which is essentially your amplitude. Now, from the graph, it's nice and easy to see. You can just count up from 7 all the way up to 13. If you're having a hard time, instead of adding 13 and 1 and taking the average, you can go the maximum minus the minimum divided by 2. 13 minus 1 is 12. 12 divided by 2 is 6. So the radius of this wheel is 6. And if you count up, these go up by ones. 1, 2, 3, 4, 5, 6. Yes, we have a radius of 6. Okay. Circumference and speed, you're going to need some formulas from grade 9, both from grade 9 math. Circumference is 2 pi r. So you're going to take 2 times pi times the radius. And you worked out the radius in the question above, and for ours it was 6. So 2 times pi times 6, you should get around 37.7 meters. So this is a very large Ferris wheel, okay, 37.7 meters. And then speed, going back to grade 9 science, you do this in math also, but distance divided by time. So how long does it take for you to travel I suppose, from here all the way around. Okay, how fast are you going? So the distance would be the circumference divided by the time that it took, divided by the time it took to complete a revolution. So this right here, this distance of a cycle, is your circumference, and then how long it took would be the period. So we're going to take 37.7 and we're going to divide by our revolution time, our 40 seconds. So 37.7 divided by 40, I got 0.94. So 0.94 meters per second. So almost a meter per second. Okay, so this is one Ferris wheel. You're going to continue to do the same for the other ones. I'm going to do just part B, and you can compare C on your own. Okay, and the whole point of today is just looking at different ones, seeing the different graphs and how the values would change for each. Okay, so I'm going to go through this one a little faster. The revolution time is the amount of time it takes to complete a cycle. In other words, we're looking for the period of the function. This one is also 40 seconds. Okay, so this has the exact same revolution time, but the height of the axle is lower. This one, if I take 9 and I add it to 1, I would get 10. 10 divided by 2 is 5. So the height of the axle is 5. And if you wanted to draw your line in at 5, that doesn't look right. See, it's kind of nice that we can check our work. The height of the axle, doesn't like it when I graph these lines. There we go. If my lowest point is 1, oh goodness, my highest point isn't 9, it's 7. That helps. There we go. Sorry, 7. So 7 plus 1 is 8. 8 divided by 2 is 4. Let's get that wrong answer out of there. Here we go. Now I can draw this in at 4, and that looks much better. So you know what? It's okay to make mistakes. And if you're looking at your graph, it's really nice to be able to compare, to double check your answers. So by all means, you know what? Do both, a graph plus the algebra, and you should always be able to double check your work. All right, so let's get back on track here. There we go. All right, well, wow, these don't like me. Okay, stop touching. The radius of the wheel should be the amplitude. In this case, we're going from 4 to 7, which is 3. The other way that you can check is take 7 and this time minus 1 divided by 2. So 7 minus 1 divided by 2. This is 6 divided by 2, which is 3. So we got the same answer. The radius is 3. The circumference, please use your formula. C equals 2 pi r. So 2 times pi times the radius, which in this case is again 3. I got 18.8. So this is a much smaller Ferris wheel than the one above. And the speed, we're going to take the distance divided by the time. The distance of a cycle, which is the circumference, divided by the time it took to get there, divided by the revolution. So 18.8 divided by 40, you should get around 0.47 meters per second. So this Ferris wheel is traveling almost half the speed of the one up at the top. Okay, you can complete the bottom one on your own. If you need more examples, they're in your book. Today for your questions, any of the ones from question 1 to 7, I really like question 7 because you're comparing, but you can do any 3 that you choose. They're all great questions, but I don't want you to be overwhelmed, okay? So pick any questions you like. Guys, have a great day. We'll see you tomorrow.